This is Nitin Dahad with the Times, and I'm on the NXP Semiconductors booth at Embedded World in Nuremberg, speaking to Rutger Vrijen. Rutger, hello.
Hi, Nitin. Welcome to NXP.
Thank you. So tell me a little bit about, well, let's start with you did a big acquisition recently, we covered it. Tell us a little bit about how that's going with the Kinara.
Yeah, so we're very excited actually to have Kinara in our demo booth here today in one of our demo setups. As you already said, we are very excited to have signed the deal with Kinara earlier in February. We have to wait for regulatory approval for the deal to close, but we're very excited about bringing them on board. And we were already working them as commercial partners, so we're well on our way to jointly go to market with our combined portfolio. And
how does that, I mean, we talked about it earlier, how does that change your relationship? It was a commercial relationship before, and it's part of a roadmap of stuff you're going to introduce, is that right?
Yes, it's now an extension of our own product roadmap by virtue of adding discrete MPUs to the portfolio, which really allows us to fully invest behind bringing that product into our lineup and part of our software offering as well, and really be able to fully commit to Kinara being part of the NXP family.
And I mean, you were talking about adding quite a few different variants from one end of the scale to another.
That's right. We were an early innovator with regards to bringing AI capabilities into our MCU and MPU platform, all the way from small microcontrollers being able to do time series type machine learning to our larger MCUs and real-time MCUs being able to do CNN type AI applications, and into our MPU family with up to 4 tops of capability to drive larger AI applications. What Kinara does, it extends that range to 6 tops with the RL1 and 40 tops with the RL2. So we can actually run full generative AI use cases at the edge, as we will demonstrate here today.
Okay, so tell me a little bit about the demo, and then we're going to...
So what you have in the demo here is a combination of an NXP i.MX 9.5 SoC with a Kinara MPU, the RR2.
And that's in here?
They're both in this small box.
Yeah.
And they work together to run a multimodal Gen AI use case at the edge. What we have done is we have compressed a Lava model into the Kinara MPU. 8 billion parameter model, so much smaller than what you would run in the cloud, but still very capable.
Yeah.
And we have combined that with a vision pipeline that can ingest images, send that into the Lava model for interpretation. Then that interpretation together with a prompt for a question will be sent into the large language part of the model and provide a fully descriptive interpretation back of what is going on in the image.
Okay. What else is there in your sort of strategy for AI?
Well, let me finish one thing that I didn't say here, which is it's important to understand that this is running fully at the edge. Meaning there is no connection to the cloud.
Okay.
Everything is done completely locally. That means it's low latency, it's secure, it protects the privacy of your data. You don't have to send your data into the cloud if you want to add proprietary data to the model.
Yeah.
So the strength here is really to be able to run completely remote. And how that fits into our strategy is NXP intends to be the leader for intelligent systems at the edge. That means intelligent systems in our end nodes, cameras, sensors, autonomous devices at the edge, but also aggregated in local hubs that combine information from different end nodes that are important for a larger system, such as a smart building where you want to control temperature, multiple rooms, and be energy efficient with solar power generation, etc. Okay.
We're going to do a little demo, aren't we?
Alberto's going to talk us through the different things that we can show with the Lava model compressed into the i.MX 9.5 and Kinara R2 setup here.
Well, Rutger, thank you very much.
Dylan, thanks so much for joining us here.
Alberto Alvarez, hi. How are you? Walk us through what you're doing here.
Sure, yeah. So we have here our multimodal Gen AI demo,
Yeah.
and we are going to show you how we can analyze images completely running at the edge. Everything you see here is running locally. There is no connection to the internet, so it's very private, it's secure, it's low power consumption, and low latency. So let me walk you through the demo. So here we have this image that we have chosen because it's a very challenging image. It has water on the floor, and we are going to then ask the system to try to describe what it sees. And the way it does it is by having this multimodal Gen AI demo model here, which is called Lava. And Lava has a vision encoder that can extract the features from the image and then be able to describe what it sees. So we can see here that it's generating the description with natural language. And if you read it, it says there is visible water in the floor. So it's capable of detecting the water. And when it finishes, the model already knows about this image. So I can continue asking about it and have more specific details from what it says. So let me ask now a different question, like for example, so I have asked, is there water on the floor? And now it's going to be very specific. It says, yes, there is water on the floor. And after just 1.5 seconds, I got the response.
Yeah.
So now we can also use our vision pipeline to show you like what's in the surroundings and capture what's happening, right? Let me take a picture, and I will then ask it to describe the image.
We have some smiley faces watching us.
Yeah, so, and this is really good because it will give you a very detailed description, and you can think of applications like where you have only one camera and you don't have sensors and you want to know what's happening, so then you can have this system go and analyze the image and give you all the information you want to know, right? So it's saying, yeah, the image shows a group of people in what appears to be an indoor event space.
They're smiling at the camera.
At a conference or exhibition. So it's doing a very good description.
Black pants and pink blazer. Yes? Okay, good.
Good, thanks. So now we can use this in a real case application. So let me cancel this one and I'll walk you through our...
So,
Sure.
how is this trained? What is your Lava model?
Yeah, so models are trained, in these GPUs, but we are taking them from the open source community.
Oh, I see,
And
okay.
now we give the entire solution so you can deploy the model on the NPU.
Okay,
Right?
okay.
So we showed this video where there's an accident, and we are sampling the video.
It's a bad accident.
Yeah, it's a bad accident. And we are sampling it, and we are sending the frames to the LLM, and we are going to ask it to describe what it sees. So let me type that. And it's going to go through all the frames. So we are showing the previous summary here.
Yeah.
But if you read through it, it will say like, hey, there was an unexpected event, there's an incident, the material is scattered throughout the area, there is the risk. So you can think of a system that wants to, take care of all the compliances, the safety, security reasons, that maybe you want to be sure that there's no, problem where you are working.
Sure.
Also, if the people is, passing by and you want to know if they are wearing the security helmets and all this kind of things that is important, right? So now you have a system capable of analyzing what it sees, and we can then build an agent on top of this, like the agentic AI that everyone is talking about.
Yeah.
Well, this is basically what you need to be able to do that.
Okay.
All right.
Well, Alberto, thank you very much.
Thank you, Nitin.
Thank you.